not many of you were here. I don't know if those of you who weren't here bothered to read the slides. The video is not on YouTube yet. So maybe I'll go back a little bit from where we were at the end of last week. So this is what I was hoping to get through. This week we'll just concentrate on getting this bit done on this. So this is next week's slides. Today's slides. Next week's slides. Today's slides. Okay, so we'll just go a few slides back from where we were at the end of the last lecture, just to remind those people who weren't there. Okay, so we had this, look at this model by this guy called Salop, and he imagines that consumers are uniformly distributed on a circle. Okay, so we're consumers randomly positioned all the way around the circle, and the circle is of circumference 1. And these consumers are going to be lazy, and it's going to cost them something to walk around the circle. Okay, so we're going to be n firms distributed around the circle. So maybe we have 1, 2, 3, 6 firms. Okay, if there's a consumer located here, if he wants to walk from there to there, he's going to pay a cost proportional to the distance he walks. Okay, so the further a consumer has to walk, the higher the cost they have to pay. Since the circle is of circumference 1, and for n firms around the circle, the distance between all of the firms must be 1 over n. Okay, so this distance is going to be 1 over n, and so all of the other distances. And if you want to buy from a firm that's selling the good at a price P, and the firm is some distance d away from you, you're going to pay total cost of P plus P times D. Okay, so P is the price of the good when you buy it, you walk a distance d, and for each kind of unit of distance you walk, you pay this cost T. So your total cost of buying from a firm that's distance d away from you is P plus TD. Can you not see it? No, okay, it's something else. Okay, and we're going to look at a 3-stage game. Okay, so firms are going to decide whether or not to enter. If they enter, they pay some fixed cost F. Then those firms that do enter get placed uniformly around the circle. And we could look at an extended version of this model where firms choose where to locate around the circle. That's a bit of a pain. Okay, so firms are just going to be positioned equally around the circle. And then firms are going to choose prices, and they're going to have 0 marginal cost, and then consumers are going to choose which firm to buy from. Okay, so you're a consumer here, you can buy from any firm around the circle. Which firm you buy from is going to be a trade-off. There's going to be a trade-off between the distance you have to walk and the price you have to pay when you get there. So how we solve this model? So we imagine that every firm apart from, say, firm I set a price P star. So all the other firms are setting a price P star, and we're just interested in what price the one remaining firm would like to set. Okay, so maybe this guy is setting a price P star, this one's P star, this one's P star, this one's P star, this one's P star. What price is this guy going to set? Okay, that's what. So this firm has 2 neighbours. Okay, there's a firm to their left that's setting a price P star, and there's a firm to their right that's setting a price P star. So consumers that are really close to this firm are going to be more inclined, are probably going to buy from that one. Consumers that are really close to this firm are probably going to buy from that one. Okay, because these consumers are lazy, they don't want to walk too far. Somewhere along these lines, there's going to be an indifferent consumer. There's going to be a consumer who's just indifferent between buying from this firm and buying from that firm. And there's going to be a consumer who's just indifferent from buying from this firm and buying from that firm. Okay? So what we do is we define X star to be the distance to the indifferent consumer. Okay, so maybe the indifferent consumer is here. Okay, this distance is X star. And there's going to be another indifferent consumer here. And this distance is also X star. Okay, so X star is the distance to the indifferent consumer from this firm I that we're interested in. So for this consumer to be indifferent, they have to get the same value from going left that they get from going right. Okay, so if this person goes left and buys from the firm who's selling at a price P star, well, they have to walk a distance that's 1 over n minus x star. So this distance is 1 over n, this distance is x star. So this distance is 1 over n minus x star. Okay, 1 over n minus x star. So if you buy from one of the other firms, you walk a distance 1 over n minus x star, you pay a price P star. Okay, if you buy from this firm we're interested in, firm I, you pay a price P, say, and you just walk a distance x star. And if you're indifferent between going left and going right, these two things must be the same. Okay, so for the indifferent consumer x star, this thing is equal to this thing. And if you look at last week's lecture slides, we do lots of things like this in a slightly simpler model where it's just a straight line rather than a circle. So if we have this equation for x star, we can solve this to find x star, and this is just linear in x. I won't go through it again, we did it last week. This gives us that the indifferent consumer is located at this distance. X star is 1 over 2n and P star minus 2. Okay, so this is the distance from our firm I, this is firm I, to an indifferent consumer. So it's distance that way, distance that way. So which consumers is the firm going to sell to? All of these consumers want to buy the good. They're all prepared to pay any price for the good. That's the assumption of the model. So the consumers who buy the good are going to be the ones in between these two indifferent consumers. Okay, so you have X star consumers buying it here. You have X star consumers buying it here. So the total number of consumers buying the good is going to be 2 times X star. So the quantity that this firm is selling is 2x star. It's selling a price P, so its profits are going to be 2x star. Okay, so just by substituting our formula for x star into this, we get this expression for profits. And the firm is going to choose price in order to maximize profits. Okay, so we just take the derivative of this with respect to P. It gives us the first order condition here. Okay, and in a symmetric equilibrium, all the firms are going to want to set the same price. Okay, they all have the same marginal cost. It's natural to assume they're all going to set the same price. So if they're all setting the same price, this optimal P chosen by firm I must just happen to be equal to P star. Okay, so we kind of guessed everyone else's solution, and now we're going to set P star equal to P. So if P star is equal to P, this is 0, that term drops out. This term here. So we just have 1 over n is equal to P over T. So P must be equal to T over n. Okay, so in the pricing solution to this game, everyone's going to set a price of T over n. The lazier people are, so the higher T is, the higher the price you can get away with charging. Where are you confused? No, you haven't? Okay, so we went through this last week, which is why I'm getting a little bit quicker. It'll be on YouTube soon. So we know what price they want to set. How many firms want to enter? Well, there's the price. So we had this expression for profits. Profits were 2x star P, which was this thing. So let's just substitute our solution for the price into that expression, and we get this expression for profits. It's just T over n squared. Okay, so profits are T over n squared, and entry costs you F. Then firms are going to enter until the profits are equal to the entry cost. Okay, so F is T over n squared, so n must be the square root of T over F. And then once you know n, you can then substitute that back into this expression for price. Okay, to find out what the price is. So the price is going to be the square root of T. So the higher the cost of entry is, the higher the price is. That makes sense. If costs a lot to enter the industry, not many firms enter, you don't have much competition, price is high. If T is very high, these consumers have very high transport costs. They're quite lazy, if you like. They don't care too much about going to the cheapest one, they just want to go to the closest one. So again, that's kind of effectively increasing firms' monopoly power. Firms can get away with charging a higher price. Okay, so you know we're doing industrial organisation. What a lot of people do who do industrial organisation is they look at regulation, whether we should be encouraging more firms or discouraging firms. You know, so is there too much competition in the energy industry or not enough? That's a hot topic at the moment. So let's find out if there's too much or too little entry in this model. Okay, so in this case, well, we care about maximising welfare, which is consumer surplus plus producer surplus, minus, sorry, it should be a minus for fixed costs. Well, I suppose you can include the fixed costs within producer surplus. And in this model, the price is just a transfer, a straight transfer from consumer surplus to producer surplus. Okay, everyone's going to buy the product. It doesn't matter what the price is, everyone buys the product. So if the price increases, all that happens is that consumers get a bit less consumer surplus and producers get a bit more producer surplus. Nothing is happening to the total quantity that's being sold. So prices aren't going to matter for maximising welfare here. To maximise welfare, all we care about is removing these inefficiencies. And the main inefficiencies is the transport cost and the entry cost. Okay, so yeah, the transport, yeah, because you know, if we've one really cheap firm and one really expensive firm, a lot of people would be walking a long way to go to that cheap firm. So that's a big inefficiency. It's a lot of wasted time walking. Whereas if they're both at the same price, then everyone walks the same distance, so it's not so bad. I did go through these calculations last week. This integral looks horrible. You know, it's a big, scary integral. You don't know where it comes from. Don't worry about it. Okay, the easiest way to see what the total transport costs are going to be is to think about a line segment between two firms. Okay, so let's think about this interval between this firm and this firm. So three firms, 1, 2, 3. Okay, let's draw it on a straight line. And so there's some okay, remember that in equilibrium everyone was selling the same price. Okay, P star was equal to P. So in equilibrium, X star is 1 over 2F. Okay. So the indifferent consumer is exactly halfway between each firm. Okay, so there's an indifferent consumer here, if you like, and there's an indifferent consumer here. Okay. That distance is X star, that distance is X star. If you're being different consumer, how far do you have to walk? Well, to buy from this firm, you have to walk a distance of 1 over 2F. Okay. So let's have a graph where we have the distance they walk on the y-axis and the location on the x-axis. So here we've got a line, and let's say this line is a height of 1 over 2. Sorry. So this person has to walk a distance of 1 over 2n. So let's have a line here that's of height 1 over 2n. And there's also a line here that's that line. Person in the middle, there's a firm here. Okay, this is where our firm PI was. Person in the middle doesn't have to walk anywhere. So he walks a distance of 0. So and people in the middle, well, the distance they walk is just going to be linear between the 2 points. Okay, I'll draw the same picture as that. So draw a picture like that. assume that 1 over 2n. Okay, so on this is a graph where we have distance on this axis. Distance, and this is kind of location. So the total distance walked by all the consumers who buy from this firm is the area of these two triangles. Okay, this is how far the furthest person walks, this is how far the closest person walks, and everything's linear. So the total distance walked is going to be the area of this triangle plus the area of that triangle. So this is just going to be 1 over 2n all squared. So that's the total distance walked by everyone. By everyone who buys from this firm. Or alternatively, if we did it in terms of cost, okay, if we did it in terms of cost instead, it's maybe what I should have done, then this person has a cost of walking that distance of t over 2n, and so does this person. Okay, so the total expenditure on walking is the area of these two triangles. So it's t over 2n times 1 over tn plus divided by 2 plus t over 2n plus 1 over 2n divided by 2. So that's going to give us t times 1 over 2n squared. And in total, so this is just for everyone who buys from firm I. In total, there are n firms. So the total expenditure on transport costs is going to be n times this amount. Okay, so total expenditure is going to be 1/4 t over 4n. We've got a t there, we've got an n squared on the bottom, but there's an n there. Okay, so there's an n on the bottom. 2 2's gives us 4. So t over 4n. And that's what I had. Okay, so the social planner is trying to minimize the total transport cost plus the total expenditure on entry. So first order condition for the social planner gives you that n is half of the square root of tn. Okay, so there's 2 times too much entry going to the social planner. Okay, so I did do that last week, so I shouldn't spend too much time on that. So now let's extend the model, change the model a little bit. So imagine that rather than being n firms around the circle, there are just 2 firms around the circle. But firm 1 is producing this product, firm 2 is producing this product, firm 1 is producing this product, 2, 1, 2, 1, 2, 1. Okay, so the firm's products alternate around the circle. So you can think of this as a model of cereals, if you like. So Kellogg's and General Mills are the 2 big cereal producers. And they produce products that are... So General Mills make Cheerios, I think. Yeah, Cheerios. It's for a Cheerios fan in the back. Is it? Okay, I got it wrong. Maybe only 3 firms. Anyway, we've got 2 in this model. So if you like, you know, the firms, so there are 2 Kellogg's products, and in between there's 1 General Mills product. So General Mills is trying to get in between each Kellogg's product to produce something to get some consumers. Okay, then because these firms are alternating around the circle, on either side of a Kellogg's product there are 2 products produced by the other company. So if you solve the model of firms alternating around the circle, you'd get exactly the same solution as you got in the original model where there are n different firms. You know, every firm is facing competition on both sides. So the indifferent consumer is going to be in the same place, the optimal price is going to be the same, everything's the same as long as there's competition on both sides. Okay, so just with 2 companies and their products alternating around the circle, they're going to set a price equal to T over N. So what's the total profit going to be? Well, the indifferent consumer for each of these firms is going to be, this distance is 1 over 2n, but they sell 1 over 2n to the left, 1 over 2n to the right. So the total quantity that each product sells is going to be 1 over 2n times 2. Okay, so just 1 over n. So each product is going to sell a quantity of 1 over n. These firms are selling a total of n products. No. Firms are selling a total of n over 2 products. Okay, Kellogg sell half the products, General Mills sell the other half of the products. Okay, so each product has a demand of 1 over n. They sell a total of n over 2 products. So we have 1 over n times n over 2 times the price they sell, which is t over n, times t over n. Okay, so the n's cancel, and this is just half t over n. Okay, what's on the slide? T over n squared is the formula we had for profit a few slides ago. So that's another way you could do it. So if they sell n over 2 products, each product makes them a profit of t over n. So let's suppose that creating a brand for Kellogg's or General Mills costs them f. Then their profits, their total profits are going to be t over 2n minus n over 2f. So n over 2f, n over 2 is the number of brands they create, f is the cost of creating a brand. So that's their total profits, including the cost of creating brands. And this thing's going to be positive as long as root t over f is bigger than n. So as long as transport costs are sufficiently high and entry costs are sufficiently low, Kellogg's and General Mills are going to make some profits. Okay. So now let's suppose that Kellogg's created its products first. Okay, so Kellogg's comes along first. Kellogg's invents the cornflake. What's the optimal thing for Kellogg's to do? How many products should Kellogg's create? Okay, well, products are only positive, profits are only going to be positive for another entrant if this thing is true. What was it? So the total number of products has to be smaller than the square root of t over f. So if Kellogg's comes along, and Kellogg's on its own creates more than half times the square root of t over f. Okay, then if General Mills came along and put a product in between, they couldn't possibly make profits. Let me say that. So we derived that condition, right, which was an inequality on n, and that, if you like, said the maximum number of products that there could be around the circle. Okay, so the market could only support 10 different types of cereal, say. Okay, so the maximum number of n around the circle where each product is still going to make a profit is 10. What happens then if Kellogg's comes along and they make 6 products? If Kellogg's makes 6 products, 1, 2, 3, 2, 3, 4, 5, 6. Okay, Kellogg's has made 6 products. If General Mills comes and creates products in between, then there will be a total of 12 products around the circle. So if General Mills entered and introduced a new cereal brand, then there would be 12 cereal brands in total. And we've already said that the maximum number of brands that the market can support is 10. Okay, so if General Mills creates its products, it can't possibly make any profits. So what Kellogg's can do in this setup is it can create lots of products to start with, and that way it can discourage the other company from entering in the first place. Okay, so this is a way of performing entry deterrence for Kellogg's. They create lots of products, even though creating extra products doesn't automatically give them extra profits. You know, even if Kellogg's just has one product, so Kellogg's just has cornflakes, everyone around the circle wants a breakfast cereal. Everyone walks all this distance to buy some cornflakes. So Kellogg's profits are highest when they only create one product. But they have an incentive to create extra products to stop other companies from entering. That's the idea.
Why don't they make 10 products in the first place?
So if they make 10 products in the first place, then each of those products will make 0 profit, basically. So, you know, if 10 is the point at which these two things are equal, then each product is making 0 profit. So what they want to do...
So why would they make 0 profit? Couldn't they just take the full profit and pay for maybe 10, not 0?
So they have some entry cost. Okay, so you know, if they just make one and they don't have a rival, they make the whole profits of the market. Okay, but so if it wasn't for their rival, they would only want to make one product. But because they're worried about the one product, because they're worried about their rival, it helps them to make some extra products in order to discourage entry by the other person. And I better stop there. I haven't got through as much as I hoped I would. It's pretty much what we did last week, I know, but there are a few more people here. So it's just provision for both of you.